All right, so if we are looking at this, let me get my red pen here. Here's your graph, right? What X values did we use? What was our smallest X value that's on this graph? 1, right? It came down here at 1, right? It's a closed circle. We went to 2, right? And there's an open circle here, but there's a closed circle here, right? So we have 1 at 2. Then we're up here at 2. And we have a closed open circle at 3, but it jumps up here. We're not talking about continuous where there's breaks or non-continuous or continuous. We're just asking what numbers we use. It went from 1 over to 4, open circle at 4 though. How do we write this? And we used everything in between here. Does everybody see how we got that? Now the range is a little weird on this one, okay? But does everybody understand how we used all the numbers 1 through 4? All right, so question, bracket or parentheses at 1? Bracket because it's included. So our endpoints are 1 to 4. Bracket or parentheses at 4? Parentheses because it's not included there. It's a whole. You have a circle. Okay, so now we're going to go to our range. Now our range is different. Okay. A lot of you are going to say we used the numbers 1 through 3. Everybody see how you could have said that? But we didn't. We used the number 1, but did we use 1.5? No. Did we use 2.5? No. So the only things that we used were 1, 2, and 3, not between them, not the ones between it. So this is weird. And you won't be tested on this. The way you do just numbers is you put it in braces 1, 2, and 3. Now again, the reason we didn't just put 1 to 3 is because if you come over here, we used 1 and it's a hole. I mean, it's a solid circle, but we didn't use anything between 1 and 2, nothing. Then we used 2 and it's a solid circle because there's solid circles in here. And then we used 3, but we didn't use anything between these. So that's why it's only the points 1, 2, and 3. That one is really weird. I always, every time I teach this, I got to figure out, is it braces? Is it brackets? Is it, because it's points. We usually don't deal with interval notation with just points. Interval isn't exactly what it says. It's an interval from here to here. But of course I threw this on here. So, okay. Just a reminder, this one right here. The domain, your X values were from, it was a solid circle at 4, and we used everything this way, everything that way. Now, again, I know we did this on Wednesday or last Thursday, but the thing about this one is a lot of people will put this backwards. They'll put 4 to negative infinity, but you read a graph for domain left to right. So negative infinity is smaller than 4. And then that's a solid circle. Now for your range, we started here. That was the lowest Y value, was a 0 where there's nothing down here. And this continues to go up, right? So it's going to go to a positive infinity this way. For the range, you read it from the bottom to the top. The smallest is 0 and the largest is infinity. Solid circles have brackets. Open circles and infinities have parentheses. Okay. All right. 10.1. All right. Do what? On range, domain left to right. Yes. Okay. 10.1. Going to try to get through 10.1 and 10.2 today. I mean, I'm supposed to get further, but I don't think so because I'm on the rampage. Okay, we'll see. We'll get as far as we can. We're now going to talk about square roots or radicals. Okay. This here The square root symbol is also called a radical, okay? A radical sign. The whole thing's a radical, and this is a radicand. I don't care if you know all this. I just am telling you because sometimes I'll use square root symbol. Sometimes I will say radical, okay? And that just means the square root or cube root or whatever. All right. Common square roots, you should already know these because we already learned the squares through 15. This is just the opposite. Square roots and squares are opposites. They're inverses of each other. So what number times itself will give us 64? 8. Now, some of you are going to talk about a negative 8. Okay? You will get to the positives and the negatives. But at this point right now, when the radical is already there, you did not add that in. It is only the positives. That's all we talk about is the positives for right now, okay? Of course, now we have this here, right? Okay, this here is similar. I don't usually write it like this, but when I'm teaching it, there's really a -1 in front of it. It is like saying -1 times the square root of 49. That's what that's saying. Well, this gives us what? 7. So you have -1 times 7, which gives us a -7. Now, that's not how I work this problem. It's just how I can teach it. This, I have to do this first. The square root of 49 is 7. Then I apply this to it, so it becomes a -7. Okay? And it's because it has nothing to do with the square root. It has to do with that negative in front of the square root. And that's because you can think of it as a -1. Now, this one right here, if you do this on your calculator, okay, some of you are going to say 5. Well, 5 times 5 gives us 25, right? Then you're going to go, oh, it's -5. What's -5 times -5? +25. This here, for now, is no solution. Actually, no. In yours, it's going to be no real solution. That's what it's going to say. For my test, if you want to put no solution, that is fine. Okay? If you go to do this on your calculator, you have to know this. Let's say second square root is 64. That gives us 8. Okay? Right here, negative second square root of 49. That gives us our -7. But watch what happens when you come here. Second square root of -25. What is your error message? Non-real answer. Anybody know about imaginary numbers, or heard of it? You know, we are not dealing with that right now. I say right now. I want to say in this class later, okay? It's maybe at the end of this chapter, and that's it. And the only reason I can remember that is because on the test, sometimes they want no solution. Sometimes I just know that that's what people put will be I. You just are further along, but at this point, we're going to say no real solution, okay? All right, right here, let's do what's underneath that radical first. That's going to give us 25. What's the square root of 25? Here, just so you know that square roots come in the same place that exponents do. Roots and exponents are opposite of each other, so they're in the same rule when it comes to PEMDAS. So what comes first? Square roots or addition? Square roots, because again, exponents come before addition. Adding and subtracting is always last, all right? So here, what I'm going to do this first, and I get 3. Then I'm going to do this, and I get 4. Now I will add them together to get 7. Do you see the difference in these two problems right here? Okay. Now, guys, your calculators will do this for you, but I would have been done with both of these by the time you even plugged in the first one. All right. So now this one says use your calculator and round to 2 decimal places. Do not do this unless it tells us. Okay. So in this section, it does. So we have to use our calculator. Now to find your square root symbol. Squares and square roots are opposite of each other. So here's your square button. Here's your square root in blue or yellow. Okay. So your square button is here and your square root is just above it. Okay. So to get to it, because it's in blue or yellow, you hit your second button first and you hit your x squared. And that's how it puts that radical. Anybody have an 83 that's got a parenthesis right now? Okay. We can just do 3. You can too, but if it was longer, put it in parentheses. Okay. I would personally just finish off the parentheses. That way you don't ever miss it. And now the thing with us is we have to move ours to the right to get it out from underneath it. Not that you have to on this problem. And it's going to be 1.73. This one right here, all you had to do is really add 2 to it, right? So you'd get 3.73, but chances are you're going to do 2 plus second square root of 3, and you're going to get 3.73. Here, you take the square root of 3 and you subtract 2. Now be careful. All right, Haley, when you do it, when we do second square root of 3, you're going to close that parenthesis and then you're going to hit -2. Okay. For us, guys, do you see how it's still underneath that radical? If you do not use that right arrow key, it's going to put square root of 3 minus 2 underneath that radical. And you'll go, oh crap, if you catch it. But make sure you move it over to the right. Now hit -2. And you get a negative 0.27. Otherwise, if you don't do that, oops, crap. If you don't use your right arrow key, this is what it's going to have. And that's going to give us 1. Because you get 1 underneath the square root. Square root of 1 is 1. So be careful. It needed to be this. And then this one here. 2 ways to do this problem. Okay. If you have the fraction key, use your fraction key. If you don't, okay, if you don't, because some of you do not have this alpha F1, 1 and have that, okay? And I'm too lazy to do that half the time, or most of the time, okay? But if you have it, let me show you this. Second square root of 3 all over 5. It gives us this. But I don't even like doing it because I don't like using it. It takes too long. I do it one of 2 ways. This is the way that I usually do it. 2 plus second square root of 3. I hit enter. Now I divide by 5. I made the calculator give me this answer up top. Now I divide by 5. And notice I got the same 0.74. But, or 75. A lot of you like to do everything at once. And if you're going to do that at once, without using your fraction key, this whole top has to be in parentheses. The whole top. Like that. Divided by 5. And if you had more than just 5 on the bottom, the whole thing would have to be in parentheses. And notice you'll get the same thing. Okay. This one right here. Cube root. Square means 2. Cube root means 3. I'm going to tell you, if you know your cubes, it's going to make your life a whole lot easier. And did I not already give you those someplace? If I did not, we'll do it now. I would know these. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. I know what 6 and 7 are, but up until you can get through it with this. Okay, you can do this on your calculator. I'll even show you how to do it on the calculator. But the whole reason I always do things without the calculator is because if I asked you what 2 times 5 was, you'd say 10, right? I can do it on a calculator, but why if I know it? It's just faster without it. Okay, so what number times itself 3 times is going to give us 27? 3. You shouldn't need a calculator for that. In fact, I don't even want you using a calculator for that. Not right now. Okay, I haven't used mine, so I don't want you to use yours. Right here, this, however, is different. Remember how we couldn't take the square root of a negative number? Let's say second square root of -1. It gives us a non-real answer. That's because a -1 times a -1 gives us a +1. Same thing with positive. Here, however, our answer is -1. Why? Because -1 times -1 times -1. We multiplied it by itself 3 times and it gives us that -1. You can take odd roots of negative numbers. Even roots you cannot. Odd roots you can. All right. And then this one here is the same as doing this. Cube root of 1 over the cube root of 8. Cube root of 1 is 1. Cube root of 8 is 2. By the way, when we do anything higher than square roots, okay, and we usually don't put the 2 in there, it's just understood that it's there. It's usually 2 through 5. Every once in a while, they'll put 6, which is 216, and they'll put 7, which is 343. Majority of the time, it's 2s, and 3s, and 4s, and 5s. That's it, okay? Because they get really big fast after that. Okay, finding higher roots. Oh, yeah. And then I was going to do this one, but it's okay. We'll do that. We'll do it first. All right. There's a button on your calculator. A lot of your buttons, if you don't see it on the screen, is under math. Hit math. For cube root, it is number 4. Okay? So for number 4, you get 4. And then you can put in -1, let's say. And it'll give us -1. Okay? Now, you can do 4th roots on your calculator with the same thing, but these are they get really big really fast when you do anything higher than squares and cubes. Chances are the answers are going to be 2, 3, 4, 5, but mainly 2s and 3s. Okay? The 4th root of 16 equals 2 because 2 times 2 is 4. Times 2 is 8, times 2 is 16. So if it's pretty big, check 2 first of all. 2 to the 4th power, it'll give you 16. Right here, this is an even root. You cannot take even root negative numbers. So this is no real solutions. Because some of you are going to say, well, what about -2? If you do -2, you're saying -2 times -2 times -2 times -2, right? Does that give us a positive or a negative? Positive. Because I know a lot of, how many of you have ever heard 2 negatives give you a positive? Okay. I hate that saying. I don't hate the saying because that's not true when you're adding. Okay, but it is true for multiplication and division. This is positive, this is positive, positive times positive gives us positive. Now, this one here, however, that is in front of it. So that all this is going to do is make our answer negative. But this here, the answer is 2. But the reason it's a -2 is because the negative's outside of that. And then the fifth root, you can take odd roots of negative numbers. This is a pretty big number, right? My guess is that it's 2. Look up here. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. I do that every single time. I count them off, okay? So this answer would be a -2. Now, I know you're going, give me the calculator. Let me do it on a calculator, okay? Well, let's do it. Where did I say things were on your calculator if you don't see it on your screen? Math. That's the first thing I look for, okay? So go under math. And you see number 5? That is where it's anything other than square root or 3. Cube root, okay? So in this case right here, you're going to type in 4, and then you're going to type in 16. And you'll get 2. Watch what happens when I put -16. 4 through to -16, it gives me an error message, non-real answer. Right here, you could hit 2 and go to it, and it's going to flash. It's like, okay, no, it's not liking it. Okay, so negative math 5, put in 4 through. Let's try this again. Negative. Well, I guess that's where it goes. Math, and then we do 5. Why is it doing that?
Maybe put in the thing first and then go back.
Yeah, I think
That's what I did.
you just put it, you did it,
Yeah,
and then you
I
went.
put it in and then
You
went back.
I'm wondering. Let's do that. Now let me see if this works. I know it's not. Oops. Maybe negative parentheses. Maybe. I don't know. I mean, if you, yes, you can do it the way you did it. Okay. Math. Then see, I don't even use the calculators for this because it's just easier for me to do it without it. Okay. Oops. 16. Then parentheses. And it gives us that -2. But again, you had to know how to do it. Like Jack did it like this. He had it like this, right?
Yeah.
Okay, he had it like that. So he brought it back up and then he inserted a negative here. But I don't know why it won't allow us to do it before that. That'll work too. Okay. All right. This one here, math 4, 5. And then this is the 5th root. And you put -32 and you get -2. Okay. There are 2 rules in math. Well, there's lots of rules. When it comes to domain, okay, square root function. The 2 things are, we can't divide by 0, right? We've already learned that one. That was our, what makes it undefined, okay? And you're going to hear this anytime we learn about domain and range. Once you learn about domain and range, there are 2 things you can't do for now. You can't divide by 0, because there's another one, but you won't learn it, okay? But you cannot divide by 0. And the other is you can't take the square root of a negative number. Now, if you don't like those words, put it in your own words. I just don't want to do all the writing, okay? Nobody told me to write words down when I was sitting in class. If I heard a teacher say it, I'm like, oh crap, I got to remember that. And I'm writing it down. I didn't wait for the instructor to say, Kim, write this down. And if I didn't like this notation, I did it in my own words because I looked at my notes when I was doing my homework. Okay. All right. Now, and here's what I'm going to, the second one, that's what we're learning now. Look at your calculator. Or look at mine. You don't have to do it. Okay. Second square root of 64 is 8, right? We already did that one. Second square root of 0 is 0. My calculator said, hey, that's okay. It can be 0 and it can be greater than 0. Because what are the types of numbers that are larger than 0? They're what? They're positive, right? So even if it wasn't a perfect square of 5, it's a positive 5, it's okay. So the way we represent all of those is we're going to say it's greater than 0. But it also can be equal to 0. And I'll get to this in just a few minutes when I'm talking about up here. All right, but this you always have to keep in mind. That's why it says when it gives us x, whatever's underneath the radical cannot be negative. They say the domain is from 0 to infinity. Now that's going to change depending on what is here, which we'll get to. Okay, so here's what we're going to do. They give us this graph. Let's first pick 0. And we're going to plug that in. I just did this on my calculator. The square root of 0 is 0. So that is the point 0, 0. Somebody give me my next x value. It's got to be greater than 0 because that's what my domain is telling me. So give me a value.
2.
2. Okay. I'm glad you picked 2. But before we do 2, let's do 1. Okay. You can keep it wherever you put it. If you put it under here, let's do 1 first. The square root of 1 gives us 1, right? So what that is the point 0, 1, 1. Now don't think it's going to be, because some of you would stop and go, oh, 2, 2, 3, 3, 4, 3, 4, 4. Prove it. Let's do 2. The square root of 2. Second square root of 2 is about 1.4. I don't like that point. It was okay. I wanted somebody to give me one that wasn't, that was going to give me an answer that way. It's not that we can't graph it, but aren't we guessing at 1.4? What kind of numbers do you think we want to pick? Anybody? Perfect squares, right? What's my next perfect square past 1? 4. So let's use 4, because that's going to be 2 times 2, right? Square root of 4 gives us 2. Ooh, I like that point. 4, 2. What's the next one? 9. Square root of 9 is 3. What would the number be if my answer is 4? What would I have picked over here? 16, right? Square root of 16 gives me 4. So 9, 3, and then 16, 4. I did 16 because my graph allows me to. Now, I am not going to graph this to 1.4. I'm not going to graph it because it's not going to be in a corner. I'm going to graph 0, 0. Right here. I'm going to graph 1, 1. 4, 2. 9, 3. And 16, 4. Now, if I wanted to, I could graph that to 1.4, probably be about right in there. It's fine. It's just a guess, though, right? And now it's a curve. It looks like this. Okay. All right. And you can even do that on your calculator. Okay. If you wanted your calculator to graph it, you go under y equals, clear whatever is out, hit second square root of x, and then hit, I hope mine's in zoom. I'm going to put it zoom 6. Not that it matters, but that's how it is. Okay. If I hit zoom 8, enter, it looks a little different. So whatever, however, it doesn't really matter. It's still the same. Okay. Now, evaluate each function. What does this tell? We've already done f of 2. We've done this. What does that tell you? What is this telling you? What x is? It's saying x is equal to 2. So what you do is you take this function, okay, And wherever you see an X, you put a 2. You're going to say 5 times 2 minus 6. Now, I am not going to use my calculator right there because it's too easy. That gives me the square root of 10 minus 6, which is the square root of 4, which gives us 2. Now it's telling us that X is negative 3. So I'm going to take out my X and I'm going to put in a negative 3. So I'm going to have negative square root of 64 minus 8 times a negative 3. So that is 6, underneath that radical, it's 64 plus 24, which now we have the negative square root of, is it 88? Okay, I am going to leave my answer that way. For now, it is fine. Because our directions do not say to, it doesn't say to round, right? So I'm going to leave it. But those of you that know how to simplify radicals, bad way of writing our answer. We'll get to it. We're just not there yet. But for right now, that's what that means. Okay, right here. Find the domain. Domain means this has not necessarily X, but what's underneath that radical? Because see here, it was okay that we had X was 3, negative 3, right? It has nothing to do with X being negative. It has to do with what's underneath here. This has to be 0 or positive. So the way we do that is we set it greater than or equal to 0 because the greater than says, okay, this has to be positive. The equal means it's okay. I did not teach this. This was something you needed to know coming into my class. It was something that was taught in 0030. Okay, so same thing, subtract 12. You get 3x is greater than or equal to negative 4, divide by 3. And x is greater than, oh, let's try 12. I'm thinking the answer ahead of time. Greater than or equal to negative 4. Okay, that's how you solve it. Do you know what there's only one thing that changes in this whole process? And that's when you divide by a negative number, your symbol switches, just as a reminder. Now, to do interval notation, here's negative 4, here's negative 3, here's negative 5. It's a closed circle at negative 4. And it's everything greater than that goes that direction because we have to write this in interval notation. Bracket or parentheses at negative 4. Bracket at negative 4, and it goes to infinity parentheses. Now, this one here, this whole thing has to be positive or 0. So you say negative 3x plus 12 is greater than or equal to 0. I'm going to take the 12 to the other side, it becomes negative. So I'm skipping that step. Now, divide by negative 3. Anytime you multiply or divide by a negative number, your symbol will switch directions. And that's because we are dividing by a negative. And you're going to get x is less than 4. So on a number line, we put 4. Close circle at 4. And it's everything this direction. Start with your negative infinity. It is smaller than 4. Parentheses here, bracket here. Again, this one right here, that whole thing, 6 minus 2x has got to be greater than or equal to 0. I'm going to take the 6 to the other side, it becomes negative. I'm going to divide by negative 2. Does my symbol stay or switch? switches y. Divide by a negative, good. You're exactly right. And you get x is less than 3. Here's 3. Okay, you're going to solid circle, and it's everything this way. Goes to negative infinity. The thing about this is most people who miss this will put 3 first. But remember, negative infinity is smaller. It goes first to 3, and it's a bracket. We will pick back up with this on